You know, one of the toughest things in any job is making a big decision when your whole team can't seem to agree. It's frustrating, right? Well, today, we're going to dive into a method that doesn't just manage that disagreement, it actually turns it into a secret weapon.
So picture it. You're in that meeting. You've got to pick a new supplier or greenlight a project. Everyone around the table is smart, everyone has a good reason for their opinion, but nobody's on the same page. What do? How do you move forward without it just being about who talks the loudest or ending up with some weak compromise that nobody's happy with?
For a long time, we've used methods that try to just average everything out and spit out one single correct answer. But here's the thing. That clean, simple number, it's usually an illusion. And worse, it hides all the good stuff, all the important details. But there's a better way. A way that actually embraces the messiness of human opinions and gives you a much more honest picture.
All right, so before we get to the cool new stuff, we really need to understand why the old way is, well, kind of broken. Let's talk about this illusion of the single perfect answer.
Let's make this real. We'll use a classic example from the research paper that introduced this whole idea. Imagine a team needs to pick a new supplier. They all agree on the 4 things that matter most: price, quality, delivery time, and support. Simple, right? The problem is everyone on the team has a different idea about which of these is the most important.
Now, the traditional way of doing things, using something like the classic Best-Worst Method, would be to take all those different opinions, feed them into a machine, and have it crunch out one final number, one single weight, for each of those criteria. It looks neat, it feels decisive, but it's way too simple.
And this is the huge problem. That single number is just a bland average. It completely erases the conversation. It doesn't tell you if the team was at war over the importance of price or if everyone was in total agreement about quality. All that nuance, all that valuable information, it's just gone.
Okay, so that's the problem, and it's a big one. It means we need to totally shift how we think about these kinds of decisions. We need to stop chasing a false sense of certainty.
And that's where something called the Bayesian Best-Worst Method comes in. This approach, from researchers Mohammadi and Rezi, just flips the whole thing on its head. Instead of forcing every opinion into one little average, it creates a picture of every possibility. It models the weight of each criterion as a distribution of probabilities.
So you see, we're completely changing the question. We're not asking what's the answer anymore. We're asking a much smarter question. What's the range of possible answers? It's just a more honest and way more powerful way to look at the world.
Okay, so you're probably thinking, this sounds complicated. But honestly, the core ideas behind how this works are surprisingly simple. It really boils down to 2 main statistical tools.
First up, to handle the inputs, your team's actual opinions, it uses something called a multinomial distribution. Now, don't get hung up on the fancy name. What it actually does is super straightforward.
Just think about it like this. Every time someone on your team says, hey, quality is about 5 times more important than price, they're basically casting 5 votes for quality's importance compared to price. The multinomial distribution is just a smart way of counting up all those votes from everyone on the team. That's it.
Okay, so that's the inputs. Now for the outputs, the final weights. For that, the model uses another tool called a Dirichlet distribution. And again, don't worry about the name. Its job is just to make sure the final results make sense, that all the weights are positive, and that in the end, they all add up to 100%.
I love this analogy. Think of all the importance you have to give out as one big pizza. The Dirichlet distribution just figures out all the possible ways you could slice up that pizza between price, quality, delivery, and support. You might get some big slices, some small slices, but you're always going to end up with one whole pizza. So, we've gone from counting votes to slicing a pizza. What does this actually get us in the real world? Well, it means we get a totally new kind of result. We're not looking at a single number anymore. We're looking at a rich, detailed landscape.
Here's exactly what that looks like. The old model would just tell you the weight of quality is 0.40. Full stop. The Bayesian model, though, gives you something so much more useful. It gives you a credible range. It says something like, look, the weight of quality is most likely somewhere between 0.35 and 0.45. It shows you the uncertainty.
And this is where it gets really powerful. A regular chart might show that quality and price have almost the same average weight. You might think, okay, they're basically tied in importance. But the Bayesian analysis shows you the story behind those numbers. It reveals that the team is really confident and aligned on the value of quality. But for price, even though the average is similar, there's actually huge disagreement and uncertainty.
That's critical information you were completely missing before.
And if that wasn't cool enough, it gets even better. Because you have this full map of possibilities, you can ask questions you literally could not ask before, like, what is the exact probability that quality is more important than price? And the model can give you a concrete answer. In this case, 87%. I mean, that is a total game changer.
So, the big takeaway here is that we've been looking at uncertainty all wrong. It's not some problem we need to get rid of. It's information. It's a resource. And this method lets you harness that uncertainty and turn it into a real strategic advantage. And look, this isn't just some academic fantasy. It's a real tool you can actually use. The researchers have made the official code available. Basically, you use that code in MATLAB, you install a free open-source tool called JAGS, and you run the model. And what you get out is that complete, rich picture of where your team really stands.
So let's just take a step back and come back to that big question we started with, the one that this whole thing was designed to solve. How on earth can we weigh criteria when we're dealing with a room full of different, uncertain, and sometimes conflicting opinions?
Well, the answer is actually kind of beautiful in its simplicity. You just stop fighting reality. You stop looking for that one mythical perfect number, and instead you embrace the entire landscape of possibilities. You replace that one fixed point with a distribution.
So I'll leave you with this question. Think about the decisions you make, at your job, in your life. Which of those could be smarter, more robust, maybe even more successful if you could see not just a single answer, but the full, honest landscape of uncertainty that surrounds it?